Well, good evening, and it was very interesting to listen to Max Fordham. And toward the end of his talk, in his last slide, he mentioned that the principles driving design are applicable not just to the architecture of physical things, but to business. And that is the subject I would like to explore in this part of the talk, and then we'll go on to our panel. So what are some of the interesting opportunities to apply design kind of thinking to the world of business and other social organizations, like a university or a healthcare system or a government institution? Now, before I do that, I think let's remember how a lot of innovation has been driven through the ages by going back to the Industrial Revolution. About 230, 240 years ago, we had some brand new technologies, steam power and related things, that started to transform the manufacturing of physical things from something that was done in a labor-intensive way to something that you can do in a much more automated, repetitive way. And over the next 100 years, we saw that the principles of design and manufacturing let us start building more and more complex and sophisticated physical objects. Then we got into the 20th century, and we developed all kinds of new tools that let us go to even more sophisticated objects. And we've had just an incredible run in applying technologies and innovation to the design and manufacturing of physical objects. How have we done that? Well, if you look at basically what we have done in designing these physically engineering objects, we have over the years learned to break them down into all the different parts that go into it. From how do you develop the right strategies and plan to figure out what to build in the first place, to how do you then architect and design it, how do you manufacture it, how do you develop a supply chain, and then the whole operations and maintenance. And we take each one of these in turn and go deeper and deeper and deeper into it, so that when it comes to these very sophisticated physical engineering systems, we have a pretty good idea of what it takes to put all of these pieces together and what degree of technology and process discipline should be applied to each of these. So that's what we do with physically engineered systems. Now, about 40, 50 years ago, we started to get the equivalent of steam power for this next phase of the economy that we are now entering, when information technologies started to appear. We started to build more and more powerful computers. Those components got cheaper and cheaper and cheaper, so things got quite a bit more interesting. And then about a dozen years ago, things got really interesting when the internet showed up, the World Wide Web appeared, and it started to change everything around it. And in fact, if somebody appointed me to declare the official time when we started to transition from the industrial age of the previous 200 years to the beginning of the knowledge age, I would pick the mid-90s when the internet and World Wide Web showed up, because everything just went into hyperspace as far as the rate and pace of change. And when you put all this together, we see that all these incredible new technologies have started to enable us to create an environment which is far more global and integrated, what Tom Friedman has so succinctly captured in his flat planet metaphor. It has enabled us to attack whole new kinds of problems that are far more market-facing and services-oriented, as opposed to only problems dealing with machines and back office. So we can now begin to apply technology to all aspects of the business and organization, but it has also created all new classes of systems that are far more complex and far more unpredictable than anything that we have had before. And if any of you asks me for an existence proof that we're living in a much more complex, unpredictable world, I would just mention the financial crisis that we are going through as probably exhibit A of what a complex, unpredictable world we are now living in. So let's look a little deeper at what's going on with very complex systems, since that is what we're talking about. And let me do that by sort of mapping out a spectrum of complex systems. At one end are the deterministic physically engineered systems that I talked about earlier, that we have one way or another mastered in the last 200 years since the advent of the Industrial Revolution. At the other end are the incredibly complex systems that biology has given us for the last billion years or so, and whereas those engineered systems were designed and built by human beings, since this is not a theological discussion, and since we are next door to the Museum of Science, allow me to say that these biological systems have come to us courtesy of these wonderfully elegant evolutionary forces that have adapted the systems and kept them going for all this time. In fact, if this was a theological discussion, I would try to argue that evolution is so elegant that it must have been divinely created and inspired. But maybe we can do that over wine later. But the new kind of system in our midst right now is this new class of people-oriented, therefore social organizational systems. And that's essentially what a business is, what a hospital in all its function is, what a university like Imperial College is, what a government department is. It's groups of people that have been organized together to accomplish such a purpose. Now, in the past, we never would have talked about a business or these organizational groupings as a system the same way I talked about physically engineered systems as systems, or the same way we talk about biological systems as systems. But frankly, what we can now do, given the new technologies at our disposal, is truly look at these businesses as a system.